All right. Is it cool, you guys, if I record this lesson? Is that all right with you guys? Yeah? You guys are cool with that? Okay. So here's what we're studying today. This is 6.1. This is Polygon. It's day number 2. So make sure you have that up in the title. There's 4 boxes that we're going to talk about. And the first one is discussing what this idea of a diagonal of a polygon is going to be. So I'll give you a second to get your... Okay. So imagine this diagram, that these are a bunch of people standing around in a circle, okay? So I might ask you, let's get this concept of a diagonal down. If I am person D for Diorio, okay, who are my diagonals then? Can you tell me? Can you actually, let's ask this person. Abby, can you name one of my diagonals? Sorry, I'll change that for you. Yeah, this is my diagonal, and this is my diagonal. Are there any others?
Maybe I can see, but I don't know. Does it? Oh, not C. I'm just kidding. Maybe F.
You say F. Yes, you're absolutely right. Abby, why is C not a diagonal? Yeah, what do we call those things that are next to us? Consecutives, right. So C is consecutive. So C is consecutive to D, but it's not the diagonal, right? Okay, let's do a couple more here. If I asked you to take a look at vertex E, can you draw the diagonals to vertex E? What would they be? Oh, let's ask this person here. John Lopez, where you at, buddy? Okay, what's the diagonals to E? A, B, and C. You are totally correct. So can we have more than one diagonal in a polygon? Yeah, we certainly can, right? The only thing that's not a diagonal are those consecutive ones that are right next to each other. You guys feeling pretty good about that? Yeah, makes pretty good sense, right? Okay, let's apply this to a quadrilateral. Remember, a quadrilateral is a polygon that has 4 sides only. So there's something very unique and special that happens when you deal with a quadrilateral. Second box, you got it. Okay, let's ask Oscar. Where you at, buddy? Hey, Oscar, can you give me the diagonal to vertex B, please? Yeah, I'm going to draw it in there, right? So just like this. You guys agree with that? Is that true? Is that the diagonal? Is that the only diagonal to vertex B? Yeah. It is, right? Because it's a quadrilateral. So do you realize what happens here? Could I sort of break this up into, what if I drew this picture? You guys tell me if this is accurate enough for you guys. What do you think? What did I do? I split it up, right? So I can sort of add these together. Would you agree with that? All right, cool. Now, if I take a quadrilateral and I pick any diagonal, it splits my quadrilateral up into what, you guys? What's it called? What are these 2 things called, you guys? Yeah, these are triangles, right? So here's one triangle here. And here's the other triangle here. Okay, and let me ask you a question. What do all of the angles inside a triangle add up to? Which one is it? Of a triangle, Abby. Yeah. Every triangle has 180 degrees. You agree? And this triangle has 180 degrees. All right. So, if we all agree that a quadrilateral is nothing more than 2 triangles added together, then how much do the interior degrees of a quadrilateral have to be? That's right. So all of this stuff has to be, I know. That's the one that you're talking about. So it turns out, because any quadrilateral can be broken up into 2 triangles, just like I did for you right there, it turns out that our third box, there is a theorem that gives us something pretty sweet for the interior angles of a quadrilateral. So here's a third box, third idea. It's a theorem. It's our first theorem in chapter 6.1, or chapter 6. Yeah, I don't have them for you today, but we will. Yeah. Here's what it says. Given any quadrilateral, so any quadrilateral, and I'll just put quad for abbreviations. No, a quadrilateral has 4 sides. Any quadrilateral that you draw. It turns out If I want to add these all up, so check it out. Here's angle 1, here's angle 2, this is angle 3, and this is angle 4. If you add them all up, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4, if you add them all together, what do they equal? Let me ask the TD. Shanae. What do they equal when you add those all together? I have a quadrilateral. You got it, 360 degrees. That's our first theorem. It's theorem 6.1. It's super important. Make sure it's somewhere in your notes. All right, we're going to use the theorem 6.1, to help us figure out the measure of angle A and B for this last quadrilateral. So notice that I do have a quadrilateral. I've got 1, 2, I have 3 vertices, and I have 1, 2, 3, I got 4 sides. So I have a quadrilateral here. And I know something about all the angles of a quadrilateral. I know they have to equal a certain number. So, does anybody have like a good game plan here that we could sort of use? Abby, what do you think?
Okay, so 80 plus x plus 80 plus 2x plus 70 equals 360.
You got it. That's totally right. If you add up all the angles, it has to be equal to 360 degrees. So you're totally right on target here. So let's just go ahead and do that. So I'm going to say 80 plus x plus 2x plus 70 all has to be 300. Okay, what is our next step in our algebra? Let me ask Sarah. Oh, Sarah's not here today. Let me ask Michelle. Where are you? What's the next step in our algebra here? Yes, what are the like terms? Yes, 80 and 70 are like terms. So if I add those together, how much do I get? Yes, I get 150. Good. Does anybody see any other like terms there? The x's, yeah. So if I add up this x and that x, how many x's do I have total? Yeah, so plus 3x equals 360. All right, what's the next step in our algebra? Yeah. Let's subtract 150 from both sides. Perfect. Draw our line here. These cancel out. So 3x has to be, how much is 160 take away 150? Or sorry, 360 take away 150. 210, we agree? 210 degrees. Let's divide by 3. You guys know what's up. So that must mean x is 70 degrees. Okay, have we solved the problem? No. I'm so glad that you guys realize that we're not done yet. What do we have to do? Yeah, we need to plug them back into angle A and angle B, right? So the measure of angle A is twice whatever x is, so that'd be 2 times 70. So that must be 140 degrees, right? And then, of course, the measure of angle B is equal to x, which is 70 degrees. And that is your answer, everybody. I'm glad that you guys caught that. Almost everybody caught that. Said, no, we're not done. All right, questions, comments, concerns, jokes, anything? No? Okay, I want you to take 2 minutes of your time here, and I'd like you to write your summary at the very end. What did we do today? What did you learn today? How can I use today? We'll give you just 1 minute to do that. How about that? So for 1 minute, write everything at the bottom of your summary, right? Yeah, I can show box 2 for it. There you go.